Well, hello retro computing enthusiasts. Mike here. Welcome back to my channel. And this is episode, what are we up to? 14. Dealing with the Teletek Systemaster. Wow, what a long strange trip it's been from the day I unboxed this thing after I bought it on eBay. And wow, it's been upgraded quite a bit too. Look at the house it's in now. In the last video, which I'll put a link to in the upper right, got the Teletek Systemaster situated in its new S100 box, and it's just happy as a clam in there. And yeah, there it is. Got the wires routed better for the serial port out the back the way they're supposed to be. So the lid can close. Keeps the noise down a little bit, but it's still pretty loud, as we'll find out when I turn it on here in a bit. Now, I talked in the last video about the possibility of releasing the monitor I have written for the Teletek Systemaster. I'll give you a little bit of a backstory on it. The Systemaster comes with basically a boot ROM only, okay? It has just enough intelligence in that 2K ROM to boot the system up into CP/M off of 8-inch floppies, which was the way things were done back in the day. There's nothing else on that ROM. It doesn't do anything else, okay? And I have had zero luck getting floppy drives to work with the Systemaster. I've tried floppy emulators. I just can't get it to work. And I don't know if I'm just doing something wrong, I'm configuring something wrong. Maybe it's bit rot in the original ROM that came with the Teletek Systemaster, because it is over 40 years old. I don't know. But I cannot get it to work with floppies. I have images of the original Teletek boot discs, supposedly that's what they are, and I just cannot get this thing to boot off of them. So I went the route of just writing my own monitor, and it has to fit in 2K, because that's what the Systemaster came with, was a 2K EEPROM. Now, there are ways to reconfigure that on board to get up to about 32K, but you have to get your soldering iron out, and you have to put in some bodge wires, you have to cut some traces on the board. When I first got this thing, I was all concerned about keeping it original. I'm having second thoughts about that. Down the road, I may cut those traces and solder in some bodge wires so I can get a bigger ROM in there. Just because 2K is really confining. But there are some features I put in the monitor that allow you to import Intel hex files or binary files from a terminal or a virtual terminal on your, or a terminal emulator on your PC or laptop. So that allows me to extend the functionality of the system quite a bit. So I've only got 2K in there, but I was able to import Grant Searle's 8K of BASIC and put it into RAM memory and then run BASIC on this thing, which I have in a previous video. I'll put a link to that video too, rather than demonstrating it again in this video. Just keep this video from getting too long. So basically, what I've done here is I've written a monitor, and I'll give you a look at the screen here. Now this, I call this the Jazz 80 monitor, and Jazz 80, well that has a meaning because I also have a side project, a Jazz 80 breadboard computer, and Jazz stands for just another Z80 computer. So because I'm just, there's so many of them out there, I'm just joining the crowd by putting out my own Z80 breadboard computer. But I had to have software or firmware for it, so I took the monitor, the rough monitor I wrote for the Teletek Systemaster, and I've been extending it to work with the Jazz 80 breadboard computer, okay? So, and there's been some back and forth between the Jazz 80 and the Teletek. So I've actually improved the code a little bit here in the version for the Teletek Systemaster based on what I've done with the Jazz 80 computer and with the Nabu computer. Another big project I had. So the code's gotten a little bit better. In the last video I talked about the possibility of releasing it because there have been a few people who want it, who want to know what it is. I know there's a few of you out there running the Teletek Systemaster. There's not a lot of people out there using this particular hardware. It's kind of scarce. But there are a few of you, and you have been vocal in wanting to get the monitor released, so I'm going to do it. It's going to go up on my blog, and I'll put the address where you can find it up here. And don't have a GitHub account. Maybe I'll get one day. Never seem to get around to it, but I've been releasing stuff on my blog for much longer than GitHub's been around, and it just seems to work for me. So we'll put it out on the blog. So this is version 0.9.01. It fits in a 2K EEPROM. Alright, I've got my EEPROM burner down here right next to my laptop. And, you know, I'll burn burning, you know, EEPROMs are just reprogrammable these days. So I'm using 28C16 EEPROMs. A little hard to find these days, but if you look around, you can find them. So burn the monitor into one of them, and then pop it into the socket on the Systemaster. Now, I'll give you a close-up look at the Systemaster. I have a zero insertion force socket installed on the Systemaster, so I can swap the ROMs in and out really easy. It's really hard if you're going to do this a lot when you're doing software development to get the ROMs in and out of the board easily, especially when it's in the box here. It's harder to get at things. And you know, you're going to bend pins on the ROMs. The sockets are 40 years old. They're crusty. You know, it's a problem. So I'll show you how I install the zero insertion force socket on that. So we'll take a look in the box with the fan off, the loud fan off. And this is what I mean by putting the EEPROM in a zero insertion force socket. You know, these boards, they're over 40 years old. These sockets can be a little crispy. If you're going to insert and take out, you know, an EEPROM dozens of times while you're developing firmware, this is probably the best way to go. And I've soldered the zero insertion force socket on some headers because the pins on the bottom of these sockets are pretty chunky and they don't go into regular IC sockets. So I've soldered some headers onto them and then inserted the headers into the socket. And it just allows me to pull the chip out really easy when I want to reprogram it and try some different firmware. I actually have a couple of these 28C16s, and I'll just, if I want to change something, I'll program up the other one and then just swap them. And it just takes a few seconds, and we'll be up and running again on some new firmware. So yeah, that helps a lot. That helps a lot with swapping out the EEPROMs every time there's a new software update. And I highly recommend it if you're going to be working with this old hardware. Just go that route. It's not hard. You know, get yourself a ZIF socket, solder the headers on it, and then just plug it in the socket, the EEPROM socket once, and you're done. Okay? And there'll be links to everything I'm using here in the description section below this video. So there'll be links to like zero insertion force sockets, headers, EEPROM programmer, all of it. If you need it. I got a feeling a lot of you folks out there who are interested in this probably are all completely set up. Anyway, so I will put this out. It's a little bit, specific. It's more than a little bit specific for the Systemaster now. You could, if you have a different type of system out there that's based on the Z80 and has the Z80 family peripheral chips like the SIO, the CTC, and the PIO, you could probably modify this pretty easily to work just by changing some of these equates here at the top of the code where the addresses of the different peripheral ports are. But still, we've got something like the control register down here. That's going to be probably pretty specific. Both the address and the bit values are probably going to be pretty specific to the Systemaster. But a lot of advanced Z80 systems have a control register that you have to write to configure the memory or turn on and off the ROM, so on and so forth. So you could probably change that, but you're going to have to be pretty good at coding, I think, to get this working on another Z80 system that's significantly different from the Systemaster. But those of you out there who are running Systemasters and want this code, it's coming right at you, okay? So we'll do a quick demo of what we got here with this. Okay, let me close the lid, because this is loud enough with the lid closed. I may swap out the 40-some-year-old fan in this thing, which runs like a jet engine, for a couple of quieter PC fans, modern PC fans. I might do that in the future, just to my own peace of mind here in this small room where I'm working. Okay, so let's start up. Well, first off, let me show you this. Okay, this is very important. You burn this into your Systemaster and you try to boot it up. Console is on SIOB. That's the way Teletek did it, and I just followed their standard. So console is going to be on SIOB, and I have this software defaulting to 19,200 baud, 8N1. So that's what you're going to need to set up your terminal for. So that's what you need to set up your terminal for. So speaking of a terminal, let's fire up TerraTerm. Of course, I've got a USB to RS-232 adapter dongle plugged in, and then the RS-232 cable goes around to the back of the S100 box. So let's see here. We are on... That's on COM 7. The USB to serial port is on COM 7. So we'll select that. Okay. I know the font's really small. Let me see if I can get you a little closer here. Get a good focus. Okay. So we need to go in here and we need to set up our serial port to 19.2 on the baud rate, and everything else is right. 8 bits, no parity, 1 stop bit, flow control none. Okay, so we're all set up. So if I turn on the S100 box over here, there we go. Systemaster's up and running on my Jazz 80 Mon version 0.9.01. For the Teletek Systemaster, as I said before, this is a little specific to the Systemaster. We've got a fairly short list of commands here because I only have 2K to work with. But it is extensible by loading other files in off of the computer here. Like I can extend it by loading BASIC in as an Intel hex file, but I have to load it first. So, you know, if you load it, then the BASIC command works. We got memcopy, copy bytes from origin to destination, dump a 256 byte block of memory. We can do that. Let's dump some memory here. Origin, we'll just start at 0. So there's 256 bytes. The first 256 bytes of memory were in the ROM there. And if you go yes, you get another 256 bytes, and so on, as long as you keep saying yes until you say no, and then you wind up back at the command menu. You can edit memory. So let's do that. Let's go E for edit memory, and it'll ask you the address, and we'll go somewhere up in RAM. Let's go like 7,000 hex. We're up in RAM there, above the EEPROM. And okay, well 9D. Well, we can make that. Let's make it 00, 01. 02, 03, 04, 05, 06, and let's say 07, 08, 09. Okay, and then you can just keep up doing this. It'll show you what's in the RAM position, and then it'll allow you to edit it if you want to. If you don't want to edit it, you can just hit enter, and it'll show you the next position, next. You can edit or not, your choice, until you hit X, and then you're out. And let's see, if you want to go back to the command menu, you can just hit H. But let's dump that now. Let's dump that section of memory. That was 7,000 hex. Oops. I typed that in wrong. No. So let's try that again. Let's dump that section of memory. D700. So yeah, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 6, 7, 8, 9. Yep. So that works. So no. We got some other things here. We can jump to an address and execute it. So if you load a program into memory, somewhere up in RAM, you can jump to that address and execute it. I've demonstrated that in previous videos. I don't have anything else loaded in RAM, but if we jump to 0, 0, 0, 0, we'll just restart the monitor. So that works. Help just loads, help or H just reloads this screen. We've got hex load, which you can load an Intel. You can load a program in Intel hex format into the computer and then execute it. That's how I get BASIC in. You can get lots of different programs in that way. Also have a binary load program where you can just load binary into an area of RAM and then jump to it if you like. Port scan. I thought I took that out of there. I'll have to amend this. There might be a new revision before it goes on to my blog, because I took port scan out. Port scan is a tool for scanning all of the I/O ports in the system. It's helpful for mapping the configuration of an unknown system, but the Systemaster, I have all the specs on it, so I don't need that. And it tends to crash the system as soon as it touches the configuration register in the Systemaster. It crashes it. So I took that out, but apparently it is still on the menu. So I'll take that out. We got import, where you can read a byte from an I/O port. We got outport, where you can write a byte to an output port, and we got bdump, where you can dump binary data from memory into your terminal. So that's all we've got. There's not much room left in that 2K EEPROM. I could probably optimize the code a little bit and make some space for some other functions, but really what I'm going to have to do in the future, I got two different ways I can go with this basically. I can come up with some sort of mass storage solution for the Systemaster. Either try to get floppy drives working, maybe with my own code, my own bootloader code. Maybe I can get some floppy drive functionality out of this, possibly. I don't know. Floppy drives kind of on their way out. They're not made anymore. They're getting expensive. They break down. Floppy disks, very hard to find. So I don't know. My other projects, my Nabu project, my Jazz 80 project, I'm probably going to go with something like Compact Flash or SD card disk emulator. So I'm thinking the code I'm going to write for those projects, because they're both Z80 systems as well, could work with this. So what I might only have to do is write a bootloader that can talk to the CF or SD drive emulator, and I could build a little one, plug it in here, and be able to boot a full OS like CPM on this thing. So that would be a good goal for the future, I'm thinking. Or I could go ahead and modify the hardware on the board so I could put a much larger EEPROM in here, and I would have more functionality. I could have like BASIC built into EEPROM like I've done with the Nabu now. But still, that doesn't give me mass storage, so mass storage would have to be down the road, and I would like to get CPM up and running on this at some point. So probably, even if I do modify the hardware so that I can put a bigger EEPROM on it and have more stuff in ROM when the thing fires up, still I'm going to have mass storage down the road, so I might as well go that route anyway. So I don't know exactly what I'm going to do with the Systemaster in the future. I need to sit down and give that some serious thought. Let me close this door again because it's noisy. And give that some serious thought about where I want to go in the future. But, you know, if you've got a Systemaster and you needed to do something besides act as a space heater, well, here's a quick and dirty little simple monitor around for you that you can pop in there, and hopefully you can get your Systemaster up and running again. So like I said, this will be up on my blog. There will be links down in the description of the video to everything I'm using here, all the resources, including, I didn't really talk about this, asm80.com. This is an online assembler for older hardware. You can do the Z80 here, you can do the 8080, 8085, 6502, 6809, 68000, I think a few others. So you can write and assemble code online. It's really convenient because you don't have to find a cross assembler that you can install on your computer. It doesn't matter whether you're running Windows, Mac, Linux, whatever. It's online. As long as you can access the website, you can start writing code and compiling it, and then you can download the compiled code and burn it into an EEPROM and put it in your machine. I love this site. It's great. And there are some other useful online resources too that I will put links to in the description of this video, so check those out. So anyway, this will be up on my blog very soon. Probably I'll get that up before I release this video, so if you see this video, you go to the blog, you want to download it, it'll be there for you. I'll make this change. I'll get rid of the, I think I just left it on the menu here. No, I didn't leave it on the menu. I took it out of the menu. I know what I did. I left it, I will make that change I talked about. Actually, you know what? The code is up to date. I don't need to change it. The problem is the Systemaster has an older version of it burned into its EEPROM. Okay, that's where I went wrong. I thought I took that out of the code because, yeah, it's not on the menu. It's not there. It's not down here. So, yeah, I've already made that change. So this is the version that's ready to be released. It's just the Systemaster's one version behind in what's burned into its EEPROM. Okay, that explains that. Mystery solved. Okay. Well, I hope you found this video interesting, educational, informative, inspirational, useful, whatever. Give it a like, give it a thumbs up, and subscribe to see my future videos. There's going to be some more Systemaster videos in the future as I extend it. I've got some ideas for this, and I have some other S100 cards I'd like to try out in there. So subscribe to see those future videos. Check out my main channel, Omega Geek 64, where I'm always rendering down e-waste for their gold and silver content. Fascinating stuff. And I'll see you in the next video. Thanks a lot for watching this one. Bye.